those of you that have been involved in IT long term, you've watched as the way we deliver IT services has evolved. We've moved to highly virtualized environments. We've consolidated our data centers. And really, I think the next step in the evolution of the way we deliver IT services is cloud services. I was at a CIO conference a couple of months ago, and there wasn't a whole lot that everybody agreed upon, but the one thing every major CIO from every major city was doing was they were looking to implement cloud services in 2013. It was the one thing we all agreed upon. I can't speak for the way every government entity is going to deliver IT services in California, but I can tell you the way the state of California is going to do it. We're going to implement a private cloud located on our raised floor. We're going to contract for a public cloud service offering, and we're going to open that up to local government entities to utilize. So that's the direction the state of California is going. I really believe that offering cloud services is going to fundamentally change the way we deliver IT services in the state. It's going to make us much more successful. And I really believe it's the future of IT services, which kind of brings me to introducing our first keynote speaker. He's a futurist for Intel, so he's going to tell us the way things may be in 10 to 15 years. He refuses to tell me who will win the Super Bowl, but anyway, could we have a big round of applause for Brian David Johnson?
Good morning, everybody. Excellent. So I was very honored when Russ and Ron and Carlos invited me to come and speak to you this morning. And we'll kind of get into my passion behind what I do. But then in light of Secretary Ramos's invitation for the private sector to move to the public sector, I realized I actually might be in the midst of a job interview. Because I don't think the state of California has a futurist. Maybe you need one. But unfortunately, so I do have to confess that I'm actually not from the great state of California. I am from your little sister state, north. I'm from Oregon. It's very green up there. My employer, however, is based here. Intel certainly is based in Santa Clara, and I'm actually a professor teaching MBA class at a college here in California. So I've got a lot invested in California. What I wanted to do today is talk to you a little bit about what I do as a futurist, why Intel has a futurist, sort of how I go about envisioning the future and the things that I do, and talk about that. But then very specifically, I want to talk to you about, from the public sector, the effect that you can have on the lives of people. And this is why I came. This is why I was honored and really did, all joking aside, really did want to come and talk to you, because I think that the work that you are all doing and the work that you will all do is incredibly important. And I want to kind of walk you through some of the things that I've been seeing and maybe get your mind kind of set a little bit into the future as you go through the day's events and the conversations and the things that you learn to maybe push your vision out just a little bit. So the name of my talk is Engineering the Inevitable, which sounds a little, I think sounds a little scary, but it's not meant to sound scary. It's something that I've not really talked about in front of many audiences, but I think it's something that specifically for this audience is incredibly important. So what I'm going to do before I begin also is I'm going to set my timer so that we have enough time for questions. So please start thinking questions, start writing them down. I saw there's pads of paper right there, so don't be afraid, and I'll set my timer. And we'll begin. Okay. So, this is my first slide. If you read my first slide very carefully, you will see it says that I work for a large company and we have a lot of lawyers. There, I got that one done, right? Okay, so who am I? As Ron was saying, I'm Intel's futurist. So it's my job to look 10 to 15 years out and model how people will act and interact with technology. And I do it through a mix of social science, of technical data, of statistics. I work with economists, and I create these models. And the models really are meant to describe what it will feel like to be a human 10 to 15 years from now. Now, that might sound a little bit like science fiction, a little bit kind of out there, but for Intel, this is of vital business importance. Because at Intel, it takes about 5 to 10 years for us to design, manufacture, and deploy the chips. So it's of vital business importance for Intel to understand today what people will want to do a decade from now, which is why kind of I have a job. And we'll talk a little bit more about that as we go into this presentation. Now, I am a principal engineer at the company, but I also have a design background, so I kind of do both sides. And you can pretty much tell everything you need to know about me by looking at this picture that's up on the screen. The tall, funny-looking bald guy, that's me. The little guy, the little good-looking guy down by my feet, his name is Arthur. And Arthur was the first robot ever created by the University of Essex Robotics Lab. So it's a robotics lab over in the United Kingdom. Now, I do a lot of work with artificial intelligence, a lot of work with robotics. But as I said, you can pretty much tell everything you need to know about me by looking at this picture, evidenced by the fact that I went all the way to England and had my picture taken with a 2-decade-old robot. You can rest assured, I am a geek. I am a huge geek. If you come here, you will feel nerd, just sort of coming off me. I love everything science. I love everything science fiction, which gives me so much passion sort of for my job, and I'm able to bring those two things together. But I figured, I'm the first speaker of the day. We're all kind of getting cozy. I'll just be honest. I'm going to get real geeky a little bit. So here we go. Now, to do what I do and to model what the future will look like, we have to have a vision. We have to have a vision for the future. You have to have something to start off with so that we can then sort of begin to build it. Again, my job as a principal engineer at Intel is to come up with these visions for the future, for how people will act and interact with technology. And then I work with my colleagues. I turn that into a specification, and then we turn that into the chip. So I just finished up the 2019 chip, and now I'm starting to work on the 2021 platform. So it is in my day job to take these visions, to take these things that I will talk to you about today, but turn them into action, to have a pragmatic vision to actually build this future. So to do that, we have to kind of start with a vision for the future. So let's start with this. So what will the future look like? So typically, we're shown these types of images when people talk about the future, right? You see these in advertising. You see it in science fiction stories. So you see it, right? You've always got kind of the good-looking guy or the good-looking gal. You've got the really cool piece of technology, and they're usually in this really tricked-out, kind of cool, modern-looking environment, right? This is what we normally get shown. I hate this picture. Now, I can say I hate this picture because this picture comes from Intel, which, as you can imagine, doesn't make me a lot of friends in the marketing department. The reason why I hate this picture is because when I look at this picture, if this is supposed to be an accurate vision for the future, I ask myself, where are the baby toys? Where are the family photographs? Right? Where are the pillows? Right? Where's the stuff that makes us human, the stuff that we surround ourselves to make ourselves comfortable? When I look at this, if we are doing the serious work of preparing and building for the future, I look at this and I find this intellectually dishonest. This is not the type of future that I want to build. I think we need to design and comprehend a future that is made for human beings, that is specifically designed for human beings in all of our complexities. I mean, humans are complicated and we have different backgrounds and we've got different views, and the future involves everybody. We always have to remember that the future involves all of us. And this doesn't cut it. So, see, it's early here, but I'm bringing it. On the next slide, I actually have a picture of what the future is actually going to look like. Who wants to see it? You actually raised your hands. You are so polite. I have to tell you, so I spend a lot of time traveling as Intel's futurist, and I travel outside the country. I do a lot of lecturing, a lot of speaking as well at universities. I was giving this part of this talk, and I was in front of 600 undergraduate engineering students, which is a tough crowd, let me tell you. You guys are pussycats compared to them. And so I get to this, right? I'm Intel's futurist, I'm there, I'm talking about the future, and I come up with this slide, and I say, okay, who wants to see the future? And I get one guy way in the back goes, sure. I come all the way out, and all I get is, sure. Okay, here we go. Hold on to something. Bam. I know, let it wash over you. Now, I have to tell you, this is an awesome future. Now, I have to tell you, being Intel's futurist and what we do, this is an awesome future. She is surrounded by connected technologies. She has a connected Ultrabook. She has a smartphone. She has a connected TV. She even has a connected picture frame. This is taken from some social science research that we did in our lab, which I'll tell you a little bit about later. But what I love about this picture as a representation of what the future will look like is it's human. It's real. Look, she's got a bunch of stuff on top of the chest of drawers. Literally, one of the drawers is open. She's in her bare feet. When I look at this, I think this is the type of future that I want to design for, right? I want to design for a future where we're surrounded by the things that make us comfortable, by the things that make us human and that make us unique. I would like to live in a future like this. I do not want to live in a future that looks like this, because this looks like prison. I don't want to live here. I want to live here. This is awesome. You probably can't see it, but all the way down here in the bottom corner, literally this pillow says, chill out. So this is the type, so when I think about the future, it's always surrounded by and rooted in humanity and designing a future for, literally for human beings. Okay, so how do we do that? How do we come up with that actionable vision for the future? Now, I have to tell you, and a lot of you folks are involved in IT, and you probably know Intel, and I work with a lot of engineers. I am a principal engineer at the company, so believe me, there's a process. It's called future casting. There's a process. The process is repeatable. You can then validate the process, then you can improve the process, and then you start all over again, and there's another process, and you keep going. So there's a process to it. I'm not going to bore you with it. But if you remember nothing else today about my presentation, please remember that I do not make predictions, right? Invariably, somebody's going to ask me who's going to win the Super Bowl. I know who we're all hoping for. Who's going to win the Super Bowl, or like what Intel's stock price is going to be. I don't know. If I knew, I would make us all rich. But I don't know. I actually don't make predictions because for me, predictions are also intellectually dishonest. Usually, if somebody's making a prediction, they're trying to sell you something. For me, if you make a prediction about the future, you're not honoring the complexity of it. Right? The future is constantly in motion. The future is made every day by the actions of people. And we can kind of get an idea based upon the work that we do where things are going, but for me, predictions are useless. And what we say in my lab and what I teach students is we don't want to make a prediction, right? We don't want to be right. You don't want to be the guy or gal who says, I was right. You want to get it right, right? You want to be the person who's rolling out services, who's making products that are actually getting it right 5, 10, 15 years from now. And that might be a bit of a subtle distinction, but I find it incredibly important because you don't want to be the one sort of sitting on the sidelines sort of taking pot shots. You want to be the one who's in there and building. So the process that we do in my lab is something called future casting. And what future casting is it's a combination of social science. So we start with social science first and foremost. So we start with human beings, getting a scientific understanding of people. Sort of what their behaviors are, where they live, how they shop, how they worship, what their relationships are. We start there. And then we mix that with technical research, kind of what you would expect from Intel, right? And so you're saying, this is what technology can do. And then we realize, okay, if this is what technology can do, how do we then make the lives of those people better, right? How do we make them happier? How do we make them healthier? How do we make them more efficient? How do we make them more sustainable? And then we kind of get to the math of the future, if you will. This is where most people start, right? This is GDP and population growth and rollout and all the numbers that most pundits will kind of give you, which I think are important, but as we all know, kind of move and change. But I think it's important to get an understanding of what the future world could look like. So you understand people, you understand what the technology can do, you understand what that world might be like that they're in, and then you begin to create these models for what it'll feel like to be a human. And that's really what future casting is all about, is developing an actionable vision for a future that we can actually then go out and build. Understanding what people want, and then using this process, right? Using this process to say, this is what we think it's going to be like 10, 15 years from now, and then turning around and looking backwards and saying, what do we need to do to get there? And one of the most important parts about this process is it honors that complexity of the future. And so it begins to say, we roughly think it's moving in this direction. And we're going to talk a little bit about that, and I think you're going to see a lot of that today. We roughly think it's going to be like this. We know we want it to be like this. We really want the future to be like this, and we know we don't want the future to be like this. So what do we have to do today to start making those decisions to say, let's move it towards where we want it to go? And that's really kind of at the core of this philosophy and the core of the thinking that I do as a futurist, is to pull in disparate inputs, begin to create a human-based model, and then begin to own the fact that by what we build today will get us closer to where we want things to go 5, 10 years from now in the future. Now, I don't know if everybody can read this, but I always like to include this quote from Isaac Asimov, who's a great hero of mine, not only because I'm a geek and he's a science fiction author, but also because he was a great nonfiction writer. He was known as the Great Explainer. He wrote over 300 books, everything from Shakespeare to the Bible to physics to the sun. He could explain everything. And he had a great way of talking about the future. He said that predicting the future is a hopeless, thankless task, with ridicule to begin with and all too often scorn to end with. And what I tell my students is, how's that for a job description? So now what I want to do is talk to you a little bit about the things that I'm seeing in my day job, in the work that I'm doing. Now, one of, I think, the most important technical milestones that is coming is that around the year 2020, the size of meaningful computational power is approaching zero. Now, I should say that this slide is a geek test. If what I just said gave you goosebumps, you are a geek. If you didn't get goosebumps, that's okay. You're going to have a great life. You're going to have an awesome social life. You may actually see the sun. As you can tell, I do not see the sun very often. You see what camp I fall into. No, but this to me is an amazing thing. And it comes from the silicon architects that I work with. The idea that meaningful computational power, so the intelligence inside the platform, so comms is different and battery is different, things like that are different, but literally the size begins to approach zero. It gets down to 14 nanometers or 7 nanometers. That's like 21 atoms across. But what that means is that if the size of meaningful computational power is approaching zero, it means we can turn anything into a computer. And this is why I think it's important. For decades in IT and in high tech, we had to ask ourselves the question, can we do something? Can we take a workstation and turn it into a PC? Can we make a PC small enough so it fits on your lap? Can we take a laptop or an Ultrabook and make it small enough so that it's a smartphone or a tablet? It was, can we do it? But if the size of meaningful computational power has approached zero, that means we can turn anything into a computer, right? We can turn that table into a computer. We could turn her handbag into a computer. We can turn my jacket. We can even turn ourselves into computers. So what that means is we don't have to ask ourselves can anymore. We have to ask ourselves what. What do we want to do with it, right? If we're surrounded by computational intelligence, if we have the ability to turn anything into a computer, why, right? What would we want to do with it? And I think there's some really meaningful reasons for us to do it, but then there's also some meaningful reasons for us to not turn your handbag into a computer. So in the modeling, I love this graphic. So I don't know if you can see it. So in the 1960s, I just got this recently. So if you look in the 1960s, can you see the woman? She has a bouffant hairdo. She has a bouffant hairdo. And if you see the guy in the 1970s, he actually has bell-bottom pants on. Now, the folks in the back may not be able to see this, but the folks in the front might get it. Can you see who the year 2010, right where it says mobile, can anybody guess who that is? See, it means you guys are so much smarter than I am. I had no idea. So literally, the graphics folks sent this to me. And I was on stage in front of like 1,000 futurists in Toronto. And I figured out, I literally was standing there, I was like, oh, look, that's Steve Jobs. And I called up the graphics folks and I said, that's Steve Jobs. And they're like, yeah, we know. It took you like weeks to figure that one out. Good job, futurist. But to me, this idea is incredibly powerful and has a lot of ramifications for what we will all do. So let's kind of get into it. Let's get into the work and the sort of the things that I'm seeing. Let's check the time. We want to make sure everybody stays on. I stay on time. Oh, we're good. So as I said before, the things that I model are what it will feel like to be a human 10 years from now. So what will it be like? One of the things is that the effect of cloud computing, the effect of big data. Now, this is one of the things that, why I was so excited to come here and the things that you'll be talking about. So for me, I live 10 to 15 years in the future. It sounds funny, right? And because I spend all of my time talking about it, thinking about it, traveling all over the world, and it starts to create a funny little shift in my head. My wife likes to joke that her husband lives his life 20 years in the future and he commutes home on the weekends, which I think she's right, which she usually is, which is why we've been together for almost 2 decades. But for me, if you remember the models that I said before, we take the social science, the computer science, the data, and we set sort of 10, 15, 20 years in the future and turn around and look backwards. So a lot of the work that I do, and this is the beginning of the inevitable, right? This is the things that we talked about earlier. There are things that we know, right? And we know them not from a point of arrogance. We just know them because it's our job to know it, right? Especially if you're here and we are thinking about the effect of cloud computing and IT on people, that's what we do. And I'm not frightened. I don't shy away from the fact to go, no, we've got a pretty good idea of what's going to happen. Now, we don't know exactly, right? We know that the future is in motion. But there are some things that we know, and the growth of cloud computing, the growth of IT, the importance of big data, I don't think can be undersold, underestimated, underpitched, and please don't underestimate it. But for a human, for the average person in the year 2023, it will feel like data has a life of its own. And what I mean by that is even today, we humans are like fire hydrants of data, right? Constantly we're spewing out data about our surfing, about our social networks, about our finances, about our health. We literally create so much data. And I guarantee you there's like some storage folks here who are like, ugh, so much data. Oi with the data. So much data, right? So we're spewing out all of this data, and it's going up into the cloud, right? And for people, it's just sort of going away. Now, it goes up in the cloud, and 10 years from now, we're going to have machines talking to machines, right? Algorithms talking to algorithms, all the different services and all the different areas sort of working through this data. Data literally will have a life of its own. This is not a bad thing. This is a good thing. When data has a life of its own, it will make us healthier, happier, more efficient, more sustainable. It will do really, really amazing things and can do amazing things. I believe this is what you are going to be discussing today. But we have to remember that data is meaningless until it touches the lives of people. So all of those ones and zeros zipping around and all of those servers and all of those lines and all of those computers are absolutely meaningless until they touch the lives of people and change their lives. Make them happier, healthier, more sustainable, make their lives better. That technology is irrelevant until it has that effect. And this is one of the things that we're working very, very specifically on, that saying the services that we create, literally down to the algorithms that we are writing, can they have a better understanding of what it means to be human? Can we understand the people who are using the products, the services, the technologies that we're designing and deploying? Can we design those in such a way so literally baked into them they have an understanding of the humanity and of how to make that humanity better? And this is not a philosophical argument on my part. We are working on these algorithms. I'm working with a brilliant software engineer. Her name is Rita. And Rita and I sit and sort of do this work and say, okay, can we design it better? Because with the increasing amount of computational power, we're actually able to do that. We can do that now, especially as you have the size of meaningful computational power approaching 0. So this secret life of data is something that will happen, is happening. But as we begin to design it, and this is one of the things we have to remember, is as we are engineering the inevitable, right? We know where things are going. We have a very good idea. How are we going to engineer it? What are we going to engineer into that? And I think when it comes to cloud computing, when it comes to the secret life of data, we can put human beings at the center of it, which I think is very, very important. The second area that I've been seeing is tied to this, the compute moves to 0. Now, for decades, again, we lived in a world where you had your devices. You had your TV, and you had your laptop, and your desktop, and you had your smartphone. Now you have your tablet and your game console. But as we move towards a time where the size of meaningful computational power approaches 0, something happens. Okay, now get ready, because this is the biggest effect that I have in my entire presentation. So get ready. So you have all of these devices, and we used to think about them as all these different devices that we had throughout our lives and connecting those devices. But as the size of meaningful computational power approaches 0 and we can turn anything into computing, these devices disappear. That's as good as it gets, people. That's it. I know it's early, but that's it. We're at the top right now. It's all downhill. You want to see it again? Because yeah, I'll show it now. I'll show it to you again. Okay, all of those devices, let's do it again for the cameras, disappear. Thank you for that. Good night, everybody. No, thank you for that. Now, why this is important, aside from my snazzy little graphic, and thank you so much for doing that, is I'm not saying that laptops and desktops and smartphones and tablets go away. Please, that's not what I'm saying at all. What I'm saying is that you have a shift in where computation resides. Right? You begin to have computation living in the cloud. You also begin to have computational living in our environments that surround us. So again, if we can turn anything into a computer, that means we could turn that table, we could turn this podium, or we can begin to turn our buildings into computers. We're already doing that. I think hopefully there's probably some folks who are doing that already. But we can begin to surround ourselves by computational power. And why I find this important is that it means how we conceptualize the things, the products, the services, the things that we are building, it becomes very different. If we're not living in a world where we're just typing away on our laptops or we're using our smartphones, but how would you change the services? How would you change even how you could imagine the things that you would build if you were essentially living inside a computer? If you were surrounded by this computational intelligence, if you were surrounded in an environment that was smart, where everything was smart and everything was communicating with each other. I think it alters how we think about what we could do. And even for some of us, when our clothes or even our bodies have some computational power, what does that do? Again, this brings us back to understanding that human effect of what it might have and what it might do on people. Now, for all of the software, do we have any software engineers? I'm an old software engineer. I used to code back when I had hair. Anybody code? Come on. I already told you I was a geek. There's one guy who's like, yeah, I kind of do code. Used to, yeah. I do have to say, so I've given you this vision of, we're going to have this ghost of computing where we're surrounded by computational power and everything disappears. Now, if you talk to people who know software, they're like, yeah, Johnson, that's great. That's not going to happen. Because I flew in last night, and of course how I flew here is I took a plane, And to book that ticket, sure, I could use the ghost of computing and all this all this intelligence. Maybe I could even book it on my smartphone. But the fact of the matter is, if I booked it on my smartphone still has to talk to Sabre. Does anybody know what Sabre is at all? So Sabre, some guys are, right? Sabre is so old, right? Sabre is the system that the airlines use to communicate with each other, right? So Sabre is the reason why when you go check in, you walk up and go, I'm Brian David Johnson, I'm flying to Sacramento, and they go, that's Johnson? So it's true. So this ghost of computing, I was talking with a group of engineers in London, and they were giving me a hard time about this. As Brian, you're talking about this ghost of computing, and they're like, you know that your ghost of computing is like Marley from A Christmas Carol. It's dragging all the legacy systems behind it, all the sins that we had behind us. So that's actually true as well, and that's one of the things about the work that I do in future casting, and I think even the challenges that we all have in sort of building what we're going to build is that you can have these two opposing ideas, right? We will live in a world where we are surrounded by computational power, and we will also, for a very long time, book our flights using Sabre. That's okay. You can have these opposing things and figure out what we need to do and what we can and can't do. So I think it's important to keep that also in mind as you're going through the day. So the final piece that I wanted to talk to you about in the research that I've been doing is something that Intel Legal always gets really scared about when I stand up and talk about it. They say, you're not really going to talk about the future of fear, are you? Oh yeah, I'm talking about the future of fear. And the reason why is we talk about the size of meaningful computational power moving to zero. We talk about the secret life of data. We can talk about the ghost of computing. I spend so much of my time outside of Intel. I spend a lot of time traveling around America, a lot of time traveling around the world. And when I talk to people about where things are going, they're really scared. That a lot of what we are doing, a lot of the technologies that we're talking about really, really frighten people. And I started doing this research, which actually has very little to do with technology and everything to do with communications and conversations and media coverage, and started digging into this fear. And the reason why this was important to me is because our brains, I'm a brain geek, so when you do brain imaging, our brains look very different when we are frightened. Our brains, we can only make 3 decisions when we're frightened. Fight, flight, or freeze. That's all we can do. You don't come up with innovative ideas from being frightened. You come up with innovative ideas when you feel comfortable, when you feel supported, when you're communicating and collaborating is where that comes from. Now, fear to me is worrisome because I don't want people to be frightened. We want to make people's lives better. But also, fear is a problem when people are making decisions. When they're making purchasing decisions, decisions about their lives, decisions about their families, when they do it from a point of fear, it worries me. And I'll give you the reason why I started all of this research actually happened several years ago, actually, when I was giving a talk, much like this, in San Francisco. And it was at the end of it, I was at the end. So I wasn't the beginning speaker, I was the last speaker. So I was the guy between the cocktails, right? So everybody was just waiting for me to be finished. And it was going on, and a guy stood up way in the back and was very upset and said he thought that smartphones and technology were stealing his daughters from him. And let me be clear, when he said smartphones and technology, he meant me. And he was mad. And all kidding aside, he was so mad, and I do this a lot. I've spent the last pretty much 2 decades doing this, that you could see the security guard moving along the back wall, and you could see the security guard getting between me and him. So I was like, no, it's okay, it's okay. And so I said, look, you are frightened that technology is stealing your daughters from you, that they're stealing their productivity, their ability to have conversations with people, their ability to engage, how would they actually get jobs? And I said, that's a good thing. You really should be scared of that. He's like, what? He's like, Intel's Futurist is telling me to be scared of technology? I said, no. I said, these devices are so new, and they were really new when we were first doing this. I said, these devices are so new, we don't know what's socially acceptable. We don't know what's culturally acceptable. We don't really know what to do with these technologies yet. We're still kind of feeling it out. But the important thing is to have a conversation about it. To have a conversation about what do we think is acceptable and what's not acceptable, and what do we think is appropriate, and what is that future we want to have with these devices. And he still wasn't buying it. He still didn't think I was doing a good job. So I said, well, let me ask you a question. Are you the type of family who watches TV while you eat, or do you not watch TV while you eat? And he goes, oh, we don't watch TV while we eat. I said, great. That's a decision you make as a father and as a family. The TV doesn't care if it's on or off, but you make a decision about that technology. And I said, that's so much of the fear that we have around technology. And being a futurist from Intel, I get a lot of questions. A lot of questions. A lot of questions about the robo-apocalypse, to be quite honest. And usually I say, no, it's not going to happen. Next. But usually with those fears, and especially like that gentleman who by the end of it, I went up to him and we started talking about it, and I said, I've learned a lot of things about what I've done. Some parents do screen time where their children only get 2 hours a night on a screen, any screen they want, but it's only 2 hours a night, and it's that sort of evolving thing. So it was a very good moment, I think, for both of us. But what I have found is that as we begin to dig into people's fears around technology, people's fears around the future and where things are going, it usually comes from a lack of information. And we usually find out that the fear is not of the technology or of the cloud or of anything like that. It actually goes back to very basic human fears about people's security, their safety, their privacy, and their control. And it's those conversations that help us kind of dispel that fear. And this is one of the things, I think, very specifically for you guys today, as you begin to think about what you might do for the state of California, is to begin having these conversations. To know, ultimately your goal could be to enrich the lives of people. But there are going to be quite a few people who are going to be frightened of it. And I think the sooner we can have conversations about it, I travel all over the world talking about fear and trying to find out what people are afraid of so that we can talk about it. I think it's very important to have those conversations because it's those conversations that help dispel this fear. All right, now we get to the part that I want to start asking you some questions, and I think that become very applicable to where things are going to go today, and specifically for the state of California. Does anybody know what these have in common? It's okay if you don't, it's early. So, and when I saw this, I was on the flight. And when I saw Cloud Computing Manager, I went, ooh, that's perfect. I'm coming to a cloud summit. So Cloud Computing Manager, app developer, elder care, market research data miner, social media manager, sustainability manager. So this comes from Forbes. These are all jobs and job functions. None of these jobs existed 10 years ago. None of them did. The pace of technology and the change of technology, if you look back 10 years ago, there's a whole new set of skills. There's a whole new set of services. Out of all of these come services. Out of all of these come ways that we touch people's lives. They become things that people interact with, things that become a part of their daily lives. I mean, let me just look at something like elder care. Right, massive. Only going to be more involved in our lives as we move towards the future. Look at, the app developer as well. If you've got a smartphone, you're dealing with an app developer and probably multiple app developers. So in just the span of 10 years, we've had this very, very large change in what we've, in the jobs that we've had. So this got me thinking about today and about what you're going to be going through and the conversations that we could have. And this got into the engineering of the inevitable, where you think about the size of meaningful computational power moving to zero, right? We know this is going to happen, right? We know that we're going to have more devices, more technology in our lives, right? We also know we're going to have more people in our lives, right? And there's a lot of things that we know are happening. We know that the growth of the cloud, the growth of big data, is important, right? And it's something that it's important because it can have a very positive effect on people, very positive effect on government, very positive effect on the private sector. We also know that we're going to be living in this world where we're surrounded by we're surrounded by computational intelligence, but then also we're going to need to tie in those legacy systems and those devices, right? We're always going to have that old TV that sits somewhere in the basement. The whole joke about technology, right? Old TVs don't die, they just move to the basement. Computers are starting to get like that as well. So we know, a lot of this stuff we know. It's our job to know, right? And it's important that we do know it so that we can plan. But one of the things that we also know, which will make a lot of people uncomfortable, and if there's any engineers in the room, they're going to get really uncomfortable. The one thing that you can be assured of is that there's going to be a lot of uncertainty. We know it. This is something that I've actually done a lot of writing about with my engineering colleagues, and I'm going to get a little nerdy with you for a second. So not only having a background in software engineering, but also doing something called systems architecture, right? Complex systems architecture, which brings together, and it usually involves not just computers, but supply chains and sales and all that type of stuff. The more complex the system, the larger the systems that you create, the more uncertainty you can be assured of. You know it. And one of the things that we've been experimenting with is there a way that you can embrace that uncertainty? Literally in your planning, and as we begin to think about it, that you begin to see that uncertainty not as something that is frightening, but as an area of opportunity. And the reason why I started thinking about this is, again, it comes from engineering, was that if you close a system, so if you create a system that is completely closed, cannot adapt, and cannot react to uncertainty, the moment you close that system, you stamp it with an expiration date. We know that, right? We know that from research, we know that from adaptive systems, that the systems need to adapt. That could be societies, that could be families, that could be relationships, that systems need to adapt. It's not the strongest or the fastest, but it's that which can adapt. And if you embrace uncertainty, it means that you are seeing this uncertainty as an opportunity, and it will actually make the things that you build more robust. It will actually, by accepting this level of uncertainty, seeing it as something good, keeping an eye on it, right? We don't want it to go really wrong, but that means that we can actually make better decisions about the future. And knowing that uncertainty will always be there. This is one of the things as a futurist I get. Let me make sure. This is a very silly story, so I have to make sure I have time to tell you my silly story. I do. Okay, good. So possibly today somebody will come up, and people will come up to me and ask, well, how do you know what you don't know? So I'm talking about the future, and they're like, how do you know what you don't know? I was like, how do you expect me to answer that question? It's a logic loop, right? It actually doesn't work. You can't know what you don't know. What you can do is recognize the fact that there will always be things that you don't know. And this is not only a negative thing. This is one of the things that I'm trying to toggle with audiences and get them to think a little bit differently. A great example is like a catastrophe. So in the planning that I do, you have a catastrophe, right? And people will ask, well, what about black swans? Well, what about these events, again, that you could not know that would happen? And I say, well, okay, when I think of catastrophes or uncertainty, I also think of it in the same way as innovation, right? Something that is good. This is something we all want. But true innovation in our long-term plans has the same effect as a catastrophe, right? By its very definition, you cannot know it is going to happen. You just can't. But the one thing you can know is that it will happen. You can know with 100% certainty that as we move into the future, you will have catastrophes and innovations. That will change everything. This is not bad. It's a culture, and this is that idea of engineering the inevitable, is understanding that this level of uncertainty will always be there. It provides opportunity, just like innovation provides opportunity, but you begin to react to it. So what I tell people is you do not react to a superstorm that hits the eastern seaboard of the United States a month before. Right? You do not respond to Superstorm Sandy a month after. You respond when you hear about it. And you create the ability to respond appropriately as it begins to change. And you find, whether it be with catastrophes or with innovations, how can you take advantage of them, right? How can you not close your system so that you can take advantage of those? And that's where one of the things that I thought, in talking with you today, that, wow, as an opportunity, and something that I find incredibly exciting, is that a decade from now, you will deliver products and services that don't even exist today. Just like boop, boop, a list of jobs that didn't exist a decade ago, how incredibly exciting to know that a decade from now, you will be touching the lives of people with services and different innovative ways that couldn't even think about today. So how do we get there? How do you envision those services? How do you envision what you can't even envision? This is my favorite quote from our CTO at Intel, Justin Ratner. So Justin Ratner, he's our CTO, he's our Chief Technology Officer. He is the geek of all geeks. He's like the geek of 100,000 geeks. He is the uber geek inside, right? To have Justin say this, he said it about 2 years ago at an event, literally gives me goosebumps, right? He said, science and technology have progressed to the point where what we build is only constrained by the limits of our own imaginations. To have the Chief Technology Officer not talk about science, not talk about technology, but say that our deficit is our own imaginations. What is that future that we want? How can we imagine it? This I find very, very powerful, and I think it's very appropriate for the work that you'll be doing. Because there's not only the nuts and bolts of doing what we have to do in our day jobs, but there's also thinking out a little bit further, right? Knowing that we're going to have this level of uncertainty. We know where a lot of things are going. So can we then use our imaginations? Because no great invention, no huge leap of science, no huge leap of technology ever happened without first having a huge leap of imagination. And it's something I think core when we do our planning and when we imagine the future that we would want to live in. So one of the things that we do is we actually use science fiction. And this makes the 13-year-old geek inside of me so happy. One of the things that we do at Intel is we have this thing called the Tomorrow Project, which is it's the public side of the future casting that I do. We have conversations with people about the future. We do podcasts. We do videos. We publish a science fiction anthology every year based upon science fact. It's one of the ways that we've found to engage with the public to say, you may not know about synthetic biology. Are you a synthetic biologist? I was actually at something once where I actually said, are you a synthetic biologist? And the person said, yes, actually, I am a synthetic biologist. And I went, awesome. Are you a synthetic biologist? But if I give you both a science fiction story based upon synthetic biology, we can then have a conversation about it, right? We can say, this scares me, this gets me excited, and it's a science-based, fact-based conversation. It's one of the things that we're using to combat that future of fear that we talked about before. And it's because science fiction gives us that language to talk about the future. It also talks about the human impact, right? Any good story is about the human impact and the cultural impact and the ethical impact. And so we use this, and it's all free. So if you ever want to look it up, I think on my final slide there's a URL. We've been doing a lot of work. We did one in Germany. We did one in the UK. We're now doing one here in the US. We just launched one down in Brazil, which I'm extremely excited about, going into the favelas, the slums of Rio de Janeiro, and actually getting their images of the future that they would want to live in or a future that they would want to avoid. I find very fascinating getting these images. And like I said, we give it all away for free. All of the authors who do any work for us, they keep their copyright. It's not that at all. It's very much just about having these conversations about the future, which is, I think, incredibly important. So now, start thinking about your questions. I also like to say, it's a wake-up call from the future. I told you I'm a nerd, right? All right, so almost done. So how do we change the future? So you've heard me say, I believe that the future is made every day by the actions of people. This is a big deal. And I feel an incredible sense of responsibility in my job. I work for a company whose motto is to touch the lives of every human being on the planet. And they're serious about it. It's literally in every single conference room. And I actually realized when they made me the Futurist that I'm working for a company that creates computational power that actually can do that, that literally can touch the lives of every human being on the planet. And I think it's an incredible responsibility. And so I actually set off talking to people about that. So I would say to people, okay, we all build the future every day. What do we need to do? And I went and I talked to some scholars, some activists, some government officials, and I asked that question, how do we change the future? How do we build a better future? And you have no idea how many people I pissed off. Like, they were like, what makes you think you can make the future? And why are you even asking this question? And this is wrong. And how did you get in here? And get out of here. But finally, I was sitting down with an activist, a political activist by the name of Cory Doctorow, and we were having this conversation, and we hit upon something that made us both go, oh, that's it. So how do you change the future? And the way that you change the future is you change the story people tell themselves about the future that they will live in. On one hand, incredibly simple. Give them a science fiction story. Talk to them about it. But on the other hand, incredibly complicated. But if it's something that we can do, if we can actually change the story that people are telling themselves about the future that they will live in, we will make different decisions. We will make different decisions about our education, about our environment, about our spending. It has a huge effect on what we do. And it's something that we do with the Tomorrow Project, but I even think in the work that you do, because you literally touch the lives of every person in California. That's what you do. And I would argue you actually will affect the lives of many people all across America and even all across the world. That simply because you are here in this room, you will be building the future. So I have a final question for you. Because you are here, because you came and you parked and you got the coffee and you got your badge, you're passionate about this. You better be, because you're here all day. If you're not, you should do something else. But you're the ones who are going to build the future. Literally, the future of this state is going to be built by you. Like, look around. Like, look, you going to build the future? It's real. It's actually real. This is something that, as a futurist, if the future is built every day by what we do, we have to have a vision for that future. Like, you have to have it. And then you've got to do something about it, because no one else is going to do it. That's what we do. I mean, the future is far too important. You can't punt. You have to do it. So my question to you is, if the future is in your hands, if the future of the state of California is actually going to be made in this room, what will you do with it? It's your decision. And it's my humble request to you is that as you begin to think about this, as you begin to design the work that you will do in your business, even in your home, in your communities, the ultimate goal should be to make the lives of people better. That ultimately, if we're trying to make people's lives better, we will do good business, we will do good works, and we will actually really meaningfully change people's lives. My final slide is the most important slide. It takes a quick story. When I was coming up through industry, I was a speechwriter. I wrote speeches for my executives. This was before I was at Intel. And there was one guy that I used to write for who in every single presentation had me include a picture of dogs playing poker. Right, you know this one, right? I was young and I didn't ask why. So I said, okay, and every presentation I had a picture of dogs playing poker. I got really good at it. Like literally if there was a screen on the wall, there was a picture of dogs playing poker. If there was a TV or a picture frame, there would be a picture of dogs playing poker, right? You know, it's with the little dog, with the bulldog. Finally, I was leaving and I had to ask him, so why did we have to have a picture of dogs playing poker in every single presentation? And he kind of smiled and said, Brian, Everybody loves pictures of dogs playing poker. Why wouldn't you include pictures of dogs playing poker in every presentation? And he was right. So I have taken on this tradition. In every presentation that I give, I don't include pictures of dogs playing poker. What I do include are pictures of animals using technology. The longer you look at this, the more freaked out you're going to get. And with that, I will say thank you very much. It has been a pleasure speaking with you.
Thank you very much. That was awesome.